We are recording. Welcome to the evening of Python coding. This time it's something new. We joined both the DC Python meetup and the Austin Python meetup, and we're doing it as a merged group. Since it's virtual, we can do this, and hopefully this will keep you interested. And we'll keep on doing it for at least a while. We're scheduled for the next 6 months. If you find it helpful, keep on coming. The evening of Python coding typically shows one demo, and we put the code so people can later look at this demo. These days we're also recording those meetups, and we'll put a YouTube channel later on. This month we have Gendron. He will talk about a very interesting library, very much related to data science. A lot of things are related to data science with Python, but this one is probably extremely helpful. It's called Pandas Profiling, and it's better that Jay explained it than me because he knows much more about it. He's an expert in it compared to me. Jay, go ahead, take it from me from this point on. Please share your screen.
Okay.
Wait, what about the link to the YouTube channel? Is that the thing that was posted above? Somebody's asking about the link to the YouTube channel.
We'll put the link on the YouTube channel later on. Thank you. So I'll put Jay?
Yep.
Okay. Go ahead. We can see it as well.
Thanks for the opportunity to give this talk. I'm excited about the audience present because I think it might be a really, really good place for them to just start digging into the harder part of data science, which is all about data. Jacob reached out to me in 2020 and he asked me a question. He said, "Do you believe in free speech?" I said, I sure do. He says, "Good, I want you to give one." So here I am. And I'm coming to you from, it's kind of interesting, the mix here, because I'm in Chesapeake, Virginia, which is some number of hours away from DC to its south. But I had lived in San Antonio for 4 years, and I currently work for a company out of San Antonio. I've been to Austin a number of times, and I really, really enjoy Austin a lot. Especially getting breakfast at some of the places on 6th Street. So earlier when we were just kind of mingling at the beginning of this, there was a number of people who joined because they've expressed some interest in data science. And one of the truths, if there are truths in the world, one is that when it comes to data science, you're going to spend 80 to 90% of your time doing one thing. Anybody want to shout out what that is?
Cleaning your data.
That's right, cleaning your data, because your model, despite the amazing and sophisticated algorithms you might have, it is limited in almost by definition. It's constrained by the data you have. Likewise, when you start a project, you may not be familiar with the data set, and so how do you quickly assess that? And I've been doing data science type work for over 15 years, and such a difference just in the last couple of years with the number of libraries that are coming on the scene that are helping in a way sort of, if not automating, I don't want to use that term, but I think it will help people understand, if not fully automating, very much standardizing and equipping us to get quickly to the point where, as that famous book goes, seeing if there's any signal in there. Because I think that's what you really want to do before you get into some modeling. You want to see if there's something there. So, fast Pandas profiling. This is something we actually use at work. This is because of its availability to everybody. And it helps us to not only get the data into our visual get the imagery out there for us, but also to record it so that when you come back to that project some months later, you can see maybe where you started and what you've learned since. For those people who are new to Python, we're not going to do a deep dive tutorial on some of the basics here, but what you're looking at now is something called the Jupyter Notebook, very much a friendly IDE, an environment for doing data science specifically. I also use PyCharm and VS Code, but when it comes to data science, this is really one of the really good IDEs for not only doing the work, but sharing it.
Tell them what an IDE is.
Integrated development environment. So it allows you to do all your work in one place. Now, when you get the link to the GitHub repository, just as a way of knowing a little bit about the information, we're going to talk about this one module that I wrote that is just there. And for people who are Pythonistas, I wrote this mess because the nature of the file, which we're going to talk about, this is just to do all the pre-processing, and it's non-value added to tonight's talk. It's just a necessary evil to get there. But you will see the folders we're going to look at today. If you are new to the Python, you can install the environment that this was built on. All those packages are here. It's a very small build. It uses NumPy, Pandas, Profiling, Jupyter, and Watermark I put in there in all my projects. You'll see what it does. And the last thing I'll point out is we are going to look at this custom YAML file to allow you to customize your stuff. And then the profiling notebook. So all of this is in the GitHub already. You can access this. And I hope that the narrative, there's only 6 cells of code in this whole demo, but there's a lot more to talk about.
So before you continue, someone is already asking, is it the same as Pandas or an upgraded version of Pandas? So tell them what Pandas is.
So Pandas is a library designed to work inside of Python. It's emulated heavily, if you're familiar with R, to make a lot of those same mentalities, specifically the data frame, available to people in Python. Pandas has been around, I think, since 2013 is when it was first presented in a conference. You can find the seminal paper on that. And it is, as Jacob said, it's ground zero. It's aside from NumPy, Pandas is the file if you're going to do any data frame and data science type work. It allows you to manipulate and get all your stuff. It doesn't do the analysis, it gets it ready for the analysis. But that's where we spend 80 to 90% of our time. Pandas Profiling is a library that it makes use. Right here, it says here, the package, this is a quote from the website, the PyPy link. It generates profile reports from the Pandas data frame. So using Pandas data frame as a base, it builds on that. I hope that answers the question.
And since we have many newcomers here tonight, tell them a little bit what the library is, because they...
Okay, excellent. So, basic Python out of the box does basic things. And then within the open source community, there's a large group of people, developers, who find new utilities for Python, meaning new uses for it. And what they will often do, it's been said, I've heard, if you think of 2 things that you need to do with Python and aren't available in a library already, you should build a library and post it for others to use. And they range from somewhat simplistic things like what you're going to see today. It's all about visual. There's nothing really heavy algorithmically going on. To some fairly industrial strength packages like TensorFlow and Keras to do big neural net projects. All these are open source libraries. Okay, so let's just take a quick stroll through the context. This demonstration is going to show 6 cells of Pandas Profiling that helps you to create an object called a profile report object, presented as either a widget or an HTML embedded iframe in this notebook. You can change configurations, and then you can send that out to an HTML file, which you can host on a website. The package, as we already noted, builds on a data frame. If you were to click on this PyPy link, you would see its homepage. we might as well just go there. And if you've not been to PyPy, this shows you how you can download the package, the library. You can learn about the homepage, which goes to its GitHub site. And they've done a nice job explaining what it can do right here. You see it's going to do a lot of things that you would do with exploratory data analysis. Tell me about the data. Give me some visuals about the data. Tell me a little bit about correlation. Again, all there to read. I'd highly recommend reading the documentation. Let me just explain the data I pulled. If you've done previous projects, the University of California at Irvine, their machine learning repository is somewhat famous for having lots and lots of different project data sets. The one we're using here is on horse colic. I'm not a veterinarian. I thought, what a good data set to use because I know nothing about the data, which is where I find myself when I'm on a new project. This website does give you some information. I wanted to bring it up because of one thing I did in the pre-processing that we won't see, is that you would find that this data is 1989. It was not saved as a CSV. It was space delimited, and the only names for the variables were these lists here: 1, 2, 3, 4, down to 28. Okay, and so I'm going to close that. And there's a little description here that says, this is from the page you just saw. It's well-documented attributes. It's got a mix of continuous, discrete, and nominal, which I was looking for in a data set, and a lot of missing values, which I was looking for in a data set. And what we're going to do here is we're going to import all those packages that we had talked about as dependencies. And
so tell them, we have really a lot of newcomers today. Tell them what does it mean, and also how do you install a package? Sorry for being so much, but this is our audience today.
Yeah, this is maybe a good mistake. I forgot to change my environment when I started here, so I'm going to have to kill this notebook. How you install it is you can do it through Anaconda. If you are going to do data science, I would highly recommend that you use the Anaconda load. If you are going to use other forms, you can always use something called pip, which I used to thought meant Python installation packages or something, but it doesn't. It stands for something else. I just learned that this weekend. Conda is the company out of Austin, and you'll see I created an environment here so that I put all my packages in there. That's why I just got the error that says it didn't exist. So I'm going to, just a little under the hood for people who are new, I'd recommend you build environments. And we're going to activate this because it has the, and while we're here, Jacob, you would ask the question, this will show you all the library packages that come along once you start installing them. This was just a few installs, but you can see it went out to Anaconda or Conda Forge, and it brought in all these are packages, all of them helper packages that just come along free for the ride. When I said I want Jupyter because I'm running in a Jupyter notebook, it brings in a lot of other things. I don't want to go too deep on any of this, but does that help?
Yeah. Conda and pip, they won't need to know because we have many newcomers. Apologies for making you go through this, but it's important. Otherwise, we lose them. This is how you install the packages. Once you install them, then you can do what Jay is going to show you now.
Right. So now I'm at a terminal window, and I'm going to go ahead and I'm going to write, because I need to restart the session I just showed you, because I didn't have the environment. This was the easy way to do it. I'm starting up Jupyter Notebook, and it's going to fire off a space here. I'm going to close this one. I'm going to close this one. And here we are at this home page. This is our old one. And we'll get back to that book. Okay. Now we're back to where we were. Make it larger. And we'll go back to that first cell and we'll run this. And what had happened before was an error because I wasn't in the environment, and when it tried to import Pandas Profiling, that library didn't exist in that environment. So it said, here's an error, I can't find it. What's nice about this for beginners is very often as you start if you saw how many packages there were, I'm only asking for a few of these. As you can see, 1, 2, 3, 4, 5, 6. Why were that long list? There's a lot of dependencies in Python. This is one thing you're going to need to be aware of. There's lots of good things to hear about with dependencies. By setting up a different environment for each of your major projects, you don't have to worry about the dependencies getting out of line. And that's why I use in mine, this is not worthy of a whole demo, but this little beauty here called watermark, once I do that and run it, it puts a watermark, it imprints what I used for this demo. So that later, if someone were to say, well, what was being used? Well, I'm using Pandas Profiling 2.9. That could be 3.0 by the time you're watching this on YouTube. And you'll say, well, that's different now. Well, this is what this demo was based on, and this watermark, this is all it does. With this little bit of coding as a command line, it just gives you some things. It can also tell you the Git repository. I think I can do that with this one. It'll tell you what repo it's located at. So, nice little package you can find out there. That's a freebie. That was a bonus. Okay, let's just talk about the data pre-processing. You can read this faster than I can read it to you. We've already talked about it from 1989. It's got 28 attributes. The 28th was seen as not useful, as noted in the first cell. It comes from this machine learning repository at the University of California at Irvine. And I developed, as I note here, my simplifying module. It's just a piece of code that I wrote that you'll notice I wrote this package, but it's not out there in PyPy, but I was able to import it as this MSM. And that's because I don't want to have to show you all the bits and pieces of the regular expressions and the like and confuse this demo, but here's an explanation of what I did. To get my column names, I did those 3 steps. It was encoded in bytes. This data was so old it wasn't even in Unicode. So I had to do the decoding of that. This was all kind of fun because I wasn't expecting it. Dropped it all to lowercase, made them all readable, and then with the data, I opened it and then dumped it out as a CSV. So we're going to run that right now. And now this is calling live, so this is fully reproducible. This went out to the University of California Irvine site just right now, pulled that data, brought it in. I processed it using that MSM module I wrote that you have available on GitHub. And I created column names and data, and now I have a data frame, and it looks like this. You can see the names, you can see some of the horrible names, but these were worse. And these names were extracted live and dynamically from that written text. There was no names, they were just labeled 0 to 28. So if you're interested in some pre-processing, I would highly recommend you take a look at that folder called the mysimplifyingmodule.py. So we're almost to where we can actually do some work. All we've done up to this point is get some data. Here is what you normally can do with Pandas, and this is why the package was built, Pandas Profiling. Normally, you get your data and you say, give me some basic descriptive statistics. How many? You can see there's 300. What's the mean age, standard deviation, the minimum, the max, and the quantiles. Now notice this has been encoded, and if you went back to the data dictionary, you would see that this age isn't in continuous numbers. This is a numerical field for hospital ID. There's a more typical one. What is the temperature levels? You can see the minimum 30 up to 184, median of 64, mean of 71. This is basically what I've been doing for years, is trying to, in my head, see the distributions in my mind. And if you've done this, you can say, I can say already that's a skewed data set because the mean and median are so different from each other. I'm not getting skewness or kurtosis. I've got to do more digging. This is the command you use for categorical inputs. You can see 361 unique types of lesions. This is the top encoding of lesions. If the data dictionary, you'd see what the first 2, second 2, and third 2, or last 2 digits represent in that coding. So the next steps in exploratory analysis in my life would be, okay, well, I've seen something. I can also tell you I got some missing data because out of 300, I got 242 here. So I know I'm missing some data, but how much, and is it important? So I would want to do things like find missing data. Check if data types need adjusting. Was it a string, but it actually should be a number? Is there any correlations that would give me a hint on modeling? I'd have to do a lot of plots of histograms, and this is 28, but I've got data sets that are 300, 400, and many more things. The Pandas Profiling package is an early generation of these type of off-the-shelf tools. There's already a replacement for Pandas Profiling. The replacement makes use of Pandas Profiling. I stayed with the first generation. So let's look at those 6 cells of code. Now we're going to actually do the work. And this goes pretty quick. In fact, there's the rest of the notebook. That's the rest of the demo. You're looking at the entirety of it. First, we need to create this object. It's from a class. And we're going to create an object called profile report. This is out of the library. It wants the data as an input. Right now, we're going to use minimal equals true. We'll see that during discussion if people want to talk about it. And I'm going to give it a title called Profile of the Horse Colic Data version 1. And I'm going to save that into an object called Profile. This happens instantly. Now I want to view the notebook as a widget. If you only wanted to do this, you have 2 cells of code and you're done. Let's run this and we're going to see the progress bars. It is doing 36 operations, and this is minified, so it's not doing some correlations we'll see later. It's already run, and now it takes more time to generate the report structure, but this only takes about a minute. As we're waiting for this to get finished and show, I'll just point out that this cell is going to do the same thing with an HTML notebook iframe, and this is just preference. These 2 commands are going to show you the exact same information. It's just whether you like to see it one way and you find it useful, or the other way. So this will pop up fairly quickly. And the reason why minimal is true is because it says in the documentation, which I highly recommend on the PyPy, hitting their website, and we should see it if we have time to discuss here a little bit later on. The documentation gives you a lot of clues as to what you can do. Let's see what's going on here. There we go. So here's the widget. Now I'm going to run this one while we're waiting. It's the same thing.
Jay, someone is asking whether the report profile method is mentioned in the profiling package.
Yes. Okay. It's pretty much its sole major method. This is the one thing you have to do with Pandas Profiling in the documentation. I'll point out that using data minimal equals true in the title, we're going to just rebuild that profile, but we're going to now, I'm going to let it run. We're going to send it, instead of to a widget, we're going to send it to a notebook iframe. Let's run that and take a look at what came out over here. This one goes a lot quicker because all the data was mostly generated. Right away, you see here, you get this little widget, and it starts showing you information about the variables. What I really like about this is that if you've done this kind of work before, you know that just building these plots can take a lot of time. And we're not going to dig into this because I'm going to dump an HTML. It's easier to peruse. And we could talk about this for 30 minutes. But you'll notice one thing that I really like about this package is it gives you some warnings right away. Now, there's some good examples that they've pulled together on the documentation that shows not only high cardinality, missing, uniform. I've had data sets where one data happened to be all ones in it, unbeknownst to me. So this right away tells you for those variables that I've got some that have 18, 23, 35%, 82% missing values. This I really like from its reproduction. It tells you when I did the analysis, how long it took to run the work. It even gives you the file that was used to generate. We're going to see the configuration file. Now let's look to see what happened down here. We're going to expand this. And you can see this is the same report out, same information, except it's done as an HTML. And this is just a question of whether you like one or the other. And this is not the full report. This is all just the variables. Like this one here, packed cell. This gives you all the statistics you saw before. first quartile, third quartile, median, the 95th and 5th. It also gives you the full range, but it also gives you the skew number, gives you the sum, the variance, kurtosis. Nice stuff. It tells you on the extreme values what were the highest and lowest extreme values. The thing I like about this is all the kinds of things I would have to drive and make individual plot after individual plot after individual plot. You build this, and you can spend the next 4 days just looking at your data and understanding it. So let's get down to this last cell so we can open up to discussion. I think it's well worth it looking at this advanced usage. This is the documentation for Pandas Profiling, and this here explains some of the options you have. And let me show you here in terms of what the HTML report gives away. For instance, the logo. I'm going to change the logo and the primary color and the width because these are all located in the YAML file. But this can tell you whether you do or don't have a lot of these. I just showed you that had skewness. If you don't want to show that, you can change things. If you had quantiles, but you're not interested in the 25th and the 75th, but maybe the 20th and the 80th, like Pareto mentality, or thirds, you can change it. So we should talk about this a little later. I highly recommend you looking at this advanced usage. And in our demonstration, the HTML that I'm going to output, I wanted to change the brand colors and the logo. In the channel file.
Before you proceed, someone's asking a question about how does it deal with non-numeric column values? What does it do?
It handles that, and in fact, it even handles the imagery. And I didn't go into that, but if you look on their website, you'll see examples they've done with EXIF imagery. It's pretty good. I took the standard YAML file and I customized it. All these things you can see, you can add some metadata. Here's where you would change those quantiles. What's the threshold for low number of categories, chi-squared? I went down here and I said, I'm going to add the Python organization logo. I'm going to change the primary color to a very famous Austin color. I'm going to change the width to true. But I have complete control over how many things are shown, how many bins in my histogram, and whether I do or don't include all the. I'm going to show you all the correlations, but you don't need to include them all because Pearson, Spearman, and Kendall are all the same. You probably want to pick one. Phi K and Kramer's are different. Let's go back to the book. And you can see here again, same object, profile report, data, title. You notice I took minimal equals true away. I'm giving it I'm passing in this custom config YAML file, which is available on the GitHub. I'm going to run that and put it in full profile. That runs instantly. Now I'm going to run this as a notebook iframe. Same thing you just saw, but you'll notice last time we were going to see 36 calculations. It says here I'm calculating the Phi K correlation. So it's doing more work. Instead of taking 1.4 seconds, it's going to take more seconds. And this is important for you to know that you can turn it off because if you're touching a data set for the first time, you may not want to run all the data correlation calculations because it's just going to take longer. You can see how much longer this is taking. It's relatively short, but now scale this up and you would see that you might be waiting. So you have full control. It's building scatter matrix, all the interactions. And then I'll tell you what's going on with the last cell. When we're done with this, in fact, I could run it now and it would run right afterwards. I will. When that runs, it's going to dump this full profile, and that's how we're going to look at it, to a file called Borskodek Report HTML. So rather than look at the HTML that's going to display as an iframe here, we're going to switch over, find that file that I just generated, and we're going to open it up in a web browser. I've successfully added these into the web servers, and you can hit it, and if you know CSS and nav bars, I've been able to customize the nav bar to do branding and put other commands like going back to our organization. So if you've got that, you can see right away though, two things. One, anybody who lives in Austin knows what that color means. I went to the UT site and found out what is the RGB for University of Texas Hook'em Horns. And I was able to brand that instead of blue, and you can see I put a Python logo up here. So it's fixable. You also see there's interactions and correlations and missing values in sample. So let me go to this horse colic report HTML, which is just generated, and let's just open that. Again, you could now have this as on your website. You're going to see the same information. Here's all those same missing values. Here's the reproduction. It took 56 seconds instead of 1. This is all the calculations it did. This, it stores the YAML that I put into it. So if you see something you like out there, you can say, well, how did he make those colors? You could grab that YAML file. Same features you saw before. But now, it also gives you, again, these three are the same, and what's nice is here is an explanation of when you use Pearson's versus Spearman's, which is monotonically increasing, versus Kendall's. Why would you use 5K for nonlinear, and why this is good for nominal. So now, again, I didn't have to build these 4, but I would want to. There's a sample of the data, and this is my favorite part. This shows you by variable how many missing values there are, and what's really neat about this is it shows you how the correlation of missing is. You can see there's no missing ages, 1 missing here, but you can start seeing that this one's very missing, and you can start seeing the way that, I really like what they did here. You can see that whenever certain variables are missing, they're all missing. Like over here, these aren't...
We have a question about what the data set size is.
This data set size is 300 observations. And by 28, and we can show that here by the, and I'm just about done. We can get into a chat. In that reproducibility, oops. Oh, what am I doing? We've got it open in the website. Didn't need to do that. Our reproduction data set. It says it's, oh, I changed all the data on that, so you're not seeing it. Here's an overview, though. It takes up 63 KBs. Here's the size of every record size. It shows you it's got 300 observations. It's got 27 variables. So how many are categorical, how many numerical? And it also does a heat map that shows correlations between missing. So you can see if one's missing the other. You can see that the one case of a missing surgery, the outcome wasn't there. So that's 100%. The more useful is over here. Things like this packed cell volume, highly correlated missing with total protein. So you learn something. I don't know anything about veterinary, but I'm going, well, obviously those two are connected. And lastly, if you're familiar with the dendrogram, where did my stuff go? Oh, I didn't show this. It automatically also gives you various scatter plots right away. Respiratory rate versus protein. Now, I will tell you that when I dumped it over into my Mac, it obscured 300. I don't know if it was doing jitter or not. When I was doing this on my Windows side, you got the full bit here. But this gives you, think about how many charts you're getting here for what I call for free. And that's it. I'd like to pause there and stop. And I think there's a lot to talk about in terms of how does this use? How have you used it? What have you, because the stories being told in his data, as Michelangelo said, he was asked, how do you do such great sculpture? He says, that's easy. The sculpture already lives inside the marble. I just have to remove the excess rock. So that's one of my famous quotes there from Michelangelo. So with that, let me turn it over to Jacob and let's have a discussion. What can I do? How can I serve you all?
Okay, so before we go to discussion, let's do a few questions. I'm trying to figure out all of those. So someone is asking, Vimel is asking, and by the way, you can just join and unmute yourself and ask a question rather than me reading it, but I'll read it for now. If I use some public library in my code, and if the publisher later changes that code, is it going to change my output? I think it's not related to this specific demo, but tell them about what happens if someone changes the library.
Yeah, very, very important, very good question. And this is why I put into my work this one little load saying I want this library called Watermark. I would recommend write it down. These are the only two things you need to learn how to use it. And there's also something out there called pip freeze. And what you're going to want to do is, if you are using a published library, is to understand what are its dependencies. What version did you... I can tell you that this works using Python 3.7 with Pandas 2.9 and Pandas 1.13. And if any of these change, all bets are off, right, Jacob? So
it's usually stable, but it's better to have things as close as possible to those versions.
Right. So I think the question from the audience was spot on. You have to be aware of what you built from, because it is a moving target out there, but you can recreate. And that's why when we talked about this right here, this environment, this is why I didn't put versions on this, okay? But if I wanted to lock this in, I would write down pandas equals 1.130, and I would share this with you, and you would bring this into Anaconda, and it would pull up those particular versions. So you could say, because they're usually all archived, so you'd still have access to the versions, and you can replicate the work. Excellent question.
Sometimes this file is just so as a YAML file. Sometimes you'll find it is something called requirements.txt. People use it like this, and some people use something called setup.py. But like, those are basically the set of libraries that people use. So it's important to say that. I want to start with a question that's kind of funny. So let's say that I want some of this information, but not exported as HTML. I want to actually probe the object that's coming back, and I want to use some of those computations to continue doing something else in machine learning. So is there a way to access this object easily and extract the information that's already computed, instead of me writing all the code or extracting only one graph and using it?
That's a really good question that I hadn't thought of.
Because it does so much for you. Why not just you use whatever it's doing and just plug it in, and instead of just figure out what it does and pull out the object to use it?
That's a good question, and I don't know the answer to that. I think for those listening, there's a lot of objects in Python as well as the R ecosystem that once you've built this object, you can probe it and probe its dictionaries of items, and what lives inside of it. Could I just grab that element? Could I grab the correlation out? Or can I grab those charts? And this particular part of the documentation under advanced usage, and this is where it talks about using minimal and how to anonymize your data. If that question's coming up, this says if you're dealing with sensitive data like health records, you can put sensitive equals true, and it takes certain things away. But under advanced usage, perhaps there's an answer to that question, and I know I'll look at that afterwards. If I find something, I'll share it with you, Jacob. But I don't know. I didn't come across it when I was reading this. But I'd be interested to know whether these parameters, if they can actually be run somehow, because this is how you interact with. And I would think that because of the API, which is down here, there may be something in the API to actually grab these components and make use of them, because these are all objects. So it seemed to me that it's possible right there to go in and grab it. So that's a great question.
Oh yeah, here it is. This is how you grab those. They give you some information about that, so you can actually probe the so you basically can use this profiling tool as something that's embedded in your machine learning pipeline.
Yeah.
And so this is really, really great. It saves you a lot of work. You don't have to. It automates a lot of things that people have done in the past. You know how many times I had to write like what's the min, what's the max of the parameters?
Yep, I hear you so much. I was so pleased when I stumbled across this, because these are all the things that, if anything, it keeps me honest, because sometimes I'll get lazy and say that variable mustn't mean anything. This runs everything, so I really have nothing to do but grab a good couple of cups of coffee and just look at the data.
Okay, guys, more questions, please, and join the discussion if you're not shy. If you're shy, use the chat.
Hey, sorry, I just asked a question in the chat, but I can repeat it.
Go ahead.
Out loud. Is there like a best practice way to probe? Like when you say probe, is that just like an open-ended kind of thing that you just?
Yeah.
Okay.
It's you have to, one of my jokes is really to be a good data scientist, you have to put the date in dating. You have to really get familiar with your data, okay? It doesn't just magically appear. It contains a lot of mysteries. Again, my Michelangelo quote, the data already has the story. You have to remove all the excess stuff and get to its core. What are the key features? And that takes some detective work. What is this histogram telling us? I don't know. I don't know much about pulse. It's not normal, right? I can tell you that already, and I didn't know that before, but every one of these would have been a plot histogram, and even though I used to write what I thought were very clever little loops, and I just generated all of them, that was amazing. This is so good. This is just, and it's storable. That HTML I can store off, and it's a permanent, you know what I mean? It's a residual record of what I did on this particular day. So I know when I did it, and I know things about the data. So probing is really just more of a generic term, but good catch.
Gotcha. And kind of a tangential question, if you don't mind.
Please.
Suppose, like this package, it seems like in the documentation they provided like kind of the class attributes and methods or whatever for us to extract. But what if there's a package that doesn't provide that for you? Is there a way to just kind of like probe the class and just like the object it returns and kind of see like what it has, or do they have to specifically like API-ify the package?
No, they don't. I've not developed a package for Python that's out there in the world, but I've developed them for myself. And it's a little less onerous than, say, an R package, which has tests before it gets. Think of R, it's got an equivalent to Apple in their app store, versus Python's a little more like Android. Okay. So I think you can put stuff out there on Python that's very low baked, but the nice thing is it is open source, and if you can read classes, you can kind of work through, especially if you have PyCharm or VS Code in a debugger, you can figure things out if you have to. Does that make sense?
Yeah, for sure.
Yeah, okay, yeah. But there is no requirement to have, but I'll tell you there's a big, I say this, I won't say there's a big business in, there are businesses like H2O, which is an automated ML model. They have a business based on open source. So there's a lot of good packages with a lot of fantastic API documentation out there. It's amazing what an open source community can do.
Jay, do you want to try and show him how you can probe a package online? Like, I know we didn't rehearse it or anything, but can you go back to the Jupyter notebook and just add another cell and just dir the object that came back to show all the sub-objects or all the properties?
Sure. You got an idea? We can do that.
Yeah, the object itself that you created, just directory it, like dir and print it out. So the one that did the computation, just let's see what's inside. You can do this in Python. Python doesn't have like private variables or anything. Everything is kind of open, unless you go into other like things that are C. But
I'll just see that. We'll just see what it. Now that's going to give the. That's interesting. So that actually just dumps the. Even though that's full profile, let's save there. I tried print.
No, dir. Dir.
Go ahead.
dir and open parentheses and the object. It will show you all the things inside.
Oh, okay. Yeah. I did not know this.
You see, it shows you all of the parameters, and now you can go inside and actually see what's inside the object. You can actually, those are objects within objects and objects. So sometimes you can just, here are like some methods that it uses. And the question is which is which, and you can actually go and probe within Python. Most of the objects you can do this. Sometimes you have some lots of like things that's like import some other languages where things don't work like this. But most of the time you can just go inside and each object in Python go inside and never touch those things that has underscores. That's the only thing. We can look at this later. I just wanted to show that it's possible to go inside the object and see what it is. Here it doesn't. I don't see anything that gives you. Yeah, I see get description, get duplicates. So maybe the get description was a function that does something inside this object.
Yeah, that might be the one where you're allowed to write your metadata. And I don't know if I wrote that right.
Get description.
So this is a new thing to me. I appreciate that piece. I didn't know. I know that I would have gone API with. That's really kind of cool. But it's all built on. See, I'm going backwards. I started using Python as a data science tool. I'm going backwards and learning object-oriented now. So there's pieces of this that are very new to me as a Python. I'm not a Python developer. I've been a user of Python libraries. So that's kind of interesting. I'm sure we got a lot of Python developers out there who are very good with the language, and that's where I'm a student, very much a new student.
Yeah. Okay, any more questions? Please jump in and ask. If not, we'll just stop the recording and go to other things. But I assume we have a lot of things to explore here, so...
As a quick question. Hello?
Yeah.
Can you hear me?
Yep.
Okay.
Go ahead.
I just want to, I think at some point you mentioned it has some similarities with R. So I wonder, say in terms of, handling, processing the data, how does it compare with the speed? Let's say, you have gigabytes of data and then you are using this library as opposed to, or comparing with, when you are using R. Do you have any sense?
I don't do a lot of big distributed computing. Jacob may have a better answer. I will tell you, I'll give you 2 points. One, this kind of discussion is out there in droves, out there in the blog space, in terms of people doing benchmarking of one versus the other. A second point is that when it gets really large, Python does have its packages for threading, distributing cores, and then of course you got the Spark family. But some of my colleagues who have used the newer tidy version R claim that they find the Tibble, T-I-B-B-L-E, to be superior to DataFrame, but that's just me sharing comments from colleagues.
Sure. Thanks.
It's hearsay.
Yeah.
Right, yeah, I mean, you know what you know, right? So, yeah.
Right.
Yeah.
I've not had that kind of project where it was just so massive that I had to worry about doing your ACCs type. I've learned OpenACC and how to take my loops and distribute them out. I've never had a project that was that massive in my work.
Sure.
What about, we're talking about size of, what about how does it handle data sets that are larger? Let's say 300 records, you can still display the image and see some of the things that whether things are missing or not, like one of the nice images you showed before. What happens if you have something which is 30,000 records? The image itself is problematic. I've done this in the past. I used the libraries out of Holoviz. They have like data shader that can show those things and actually interactively. But here I assume it uses matplotlib or some other library to display those images because I didn't see interactivity. So I'm curious, did you try it, use it once?
No. I've been very much just using, I'll say that there's integrations down here. I think it's here. Or maybe on the documentation we just saw, the integrations that it's working with, like, where's the advanced usage? We'll go backwards. Right here. I really recommend, here's some other frameworks that it uses. And, there's your PySpark, your Dask. Not familiar with Modin, VAX. In terms of user interfaces, it talks about what you can do from the command line, PyQt, Streamlit. I don't know if y'all are familiar with Streamlit. It's fantastic. I'm trying to learn that myself. So this is out of Microsoft.
What does Streamlit do?
Streamlit, I want to do it, when I get it down, I want it give a presentation on it. It's an HTML really heavily being used. The Dolly examples seem to be autonomous vehicle kind of stuff. You can see it there on theirs. It's something developed out of Microsoft, and in other words, they're integrating with lots of things. I also wanted to show here.
So Streamlit is the graphics you just showed us?
No, that it's another package altogether. It's saying that this integrates with it. And remember,
okay.
I can't remember the name of it, but there's already a package that's built on top of Pandas Profiling, and I've forgotten the name. A colleague of mine shared that with me last week. And because as a dry one, we gave this locally in our shop. But somebody had asked the question about size. Jacob, you asked the question about size. On their site, right there at the PyPy, they've given a lot of different, you can see here's a celebrity faces that demonstrates how it works on the image analysis. It talks about this one here had 32,000 observations with 14 variables. And I agree that once you start getting very large with regard to the number of variables, it becomes as crazy as if you had 1,000 and you're trying to do all the correlations. So you may want to do the minimal equals true and just get the information on the variables, and you'd have a lot of them, but it also gives you all the warnings saying, oh, you got a lot of missing or zeros. And again, these are all, oh, I guess I can open it again. All these are on their site, and they give you just many examples. One from the Netherlands I saw earlier today. There's another UCI bank data set. I haven't opened up celebrity faces, but this is what it does with 93 observations that are images, and what does it do with it? Well, this is what I'm seeing. I'm just seeing it now myself for the first time. So that doesn't seem very, very helpful.
Yeah, good to know. I'll check that out.
Okay.
Thanks.
Yeah, I thought this was a perfect package for this demo because with a short amount of time, there's just so much under the hood, and I think at its face, you know, if you walk away and a news camera was outside the door of your house and said, what did they just talk about? Just realize you have something that does a lot of work for you for free, and it lets you just explore and use your brain versus typing out all these plots. That's where I find its greatest value. It just does something for me for free, almost.
Okay.
I have a question. I'm new to Python. Can you all hear me?
Yeah, go ahead.
Thank you. Hi. Also, awesome talk. This was really great and really interesting to learn about. My question is, you have the Jupyter notebook and the YAML documents. So is it the YAML that you are telling it how you want, you're telling the program how you want all the information displayed, and then somehow you're putting that into the Jupyter notebook? I'm not familiar with Jupyter.
Yeah, I think if you wanted to walk away with the right message, if all these files here were not there, if I were to delete all these, you haven't lost a thing in terms of what Pandas Profiling can do. Because these were here as helper files for me tonight. You don't need this. The YAML environment is just there for me to allow you all to reproduce what I did, at least to get the packages. So if you wanted to set up an environment and run a conda -f environment YAML, it will install all these for you. That's just a helper, not required to do Jupyter. And lastly, the config YAML, if we went to the advanced usage of the discussion in Pandas Profiling, which now I'm getting a little, you would see here, let's just see if we can find the there it is. Let's see, not going anywhere. Let's go back to my notebook, which has a link. I just want to point out, just so there's no fear of the YAML, let's collapse these, make it a little easier to see. I'm looking for, there it is. under advanced usage, it says you can set all these options. And in one of these examples, it talks about the fact that it gives you the standard, here it is, the default configuration file. So if you don't bring in a YAML file that's config, this is already in the package. It's just, for instance, down here where it says logo, the primary color is blue, and the full width is false. You don't need to fool with this though. I didn't touch a first YAML file for years working with Pandas. Does that help?
Yes, actually, thank you very much.
Okay. Don't be afraid. It kind of touches on multiple people. If you want to customize YAML as a little way to do this, but you don't need any of the files other than the notebook to really, and in Pandas Profiling, as long as you bring in that library, you'd be off and running by just providing it a CSV, converting it to a Pandas data frame, and you're off to the races.
That's amazing. Thank you.
Okay.
Unless someone has one more question, I suggest we close the recording. We've been recording it so far. We can still talk about this after, but if someone wants to add a question, go ahead.
I had one more question. What do you do with the data that's missing? You find all this data that's missing. Do you call
great question.
Irvine and tell them they're missing some data, or what's the standard procedure for you? Just presenting, that's the bottom line of what you're doing. You're showing that this data is missing so they can go back and get the data usually, or?
No, in this case, remember that data set's from 1989. Those people are long out of the industry, right? The idea is that's a data set, it's classic, it's there, it just exists. I chose one that had high missing values because I wanted to show some of the features. I didn't want a complete set. In real practice, of course, you're going to find missing data, and then you have to look into the art of imputation and how do you impute? How do you deal with missing values? And there's a multitude of ways to deal with it, whether it's what they call missing completely at random or not missing at random, and that's a talk all in itself. But the nasties of, well, I've got some missing data. How profuse is it? Because I could just throw out every row that doesn't have a missing data, but in this data set, I'd throw out all my data. So that's a really excellent question. It's too hard to answer quickly, but no, like these UCI, it's just there as a repository of, you're trying to learn modeling, you're trying to benchmark something, everybody's got access to these, and they're kind of infamous for, you could see even the Pandas Profiling, they use the UCI. A lot of academic, I learned it because of school. They like, let's go to UCI and get the wine data set. Okay, and it's kind of a known thing. It's like the Titanic data set, it's just more of them.
Thank you.
Lousy answer, but it's a hard question. What do you do with missing? That's why you get paid the big bucks, because you got to figure that out. There's no machine that's going to tell you what to do.
It depends on the project.
I just graduated from General Assembly, and what we were told was to impute the mean rather than delete data.
Well, actually, it depends on your project, really.
It does. I think the key thing if you wanted to look further in this, there's some excellent papers out there. I don't mean scholarly papers, they're accessible papers. But you really have to ask the key question, is this data missing completely at random, or is it systemic? And I'll give you one example from my work. We were looking at something and had to do with locations of the U.S., and we were only missing 700 items out of 14,000. That sounds pretty good. And one of my colleagues said, well, we don't have a lot of time. Why don't we not just forget about those and just move on? I said, well, let me look at them tonight. I know we're under a crunch, but let me look at them tonight. Turns out it was zip code-based stuff. In the Commonwealth of Virginia, they've annotated every one of our locations as either a county or a city, because there's Fairfax, there's Falls Church, there's let me think of one. No, I can't think of one. Alexandria, the city, but there's no Alexandria County. Somebody in DC help me. Anyway, there's some
Fairfax County, Fairfax.
Yeah.
Excellent, perfect. They're exactly right. There's Fairfax City and Fairfax County. And so the U.S. Postal System, you can go onto their website, you'll find that they've added all that. Well, guess what? When we brought in the zip code parser, guess what wasn't in our 700? Not a single address from Virginia. That's not missing at random. That's a systemic thing, and we would have just ignored our people that were in Virginia. So I hope that story made sense, but you have to kind of learn whether it's just, if anybody equally can miss something in data entry, then you can say, well, it's at random, we'll just throw them away if it's not many. But if it's systemic, you've just eliminated information. Hard question. Great topic.
And it depends on the problem. It depends on how valuable that is, in
Yes.
your case. So.
In our case, it was a small amount of data, but we would have lost an entire state because every Virginia address was problematic. We would have just missed all of them, which isn't then representative of us, right? And who wants to do terrible things to Virginians? I mean, not me.
Some of my best friends are Virginians. Anyone else has a pressing question that we want to on the record? Okay, pressing question going once, pressing question going twice, pressing question going times. Okay, we're gonna stop the recording. Hang around. We're not stopping the meetup. Now's the interesting stuff after we stop the recording. But before we stop the recording, I want everyone to thank Jay, clapping, I don't know, signaling, chatting, any way you want to make some noise.
Thank you.
It was fun.
Yeah. Okay. Thank you. We're stopping the record. Oh, it's very nice. It's being recorded. All of those. Nice. Okay. Jay, stick around. We're not ending the meetup yet. We're just ending the recording.